Okay, so good evening everyone. Hello all of you. This is Suyaj Bajpai here in front of you. अपने last lecture में, in the last lecture we have gone through, we have discussed the basic topics of what is position, what is displacement, and what is velocity and what is acceleration. We have discussed a lot of basic formula of velocity. Okay, we have discussed what is average velocity, we have discussed what is speed, average speed, we have discussed what is acceleration. The rate of change of velocity means final velocity minus initial velocity divided by time. Okay, all right, and we have seen one numerical based on that. Okay, one numerical in which we have find average speed, average velocity, average acceleration, right student? So now here in this lecture, we'll go with some basic numerical first, and then we will discuss the concepts of instantaneous velocity, okay, and the concept of instantaneous acceleration. All right everyone, so we will go through this today in this lecture. We will cover this and we will see some basic examples, okay, which will generate a good clarification in the concept of instantaneous velocity and instantaneous acceleration. All right, so without any further ado, let's start with this numerical first. So students, here this is a numerical here in front of you. A particle goes along a quadrant from A to B, right, of a circle of radius r is given to you, right, in centimeter, with a constant speed of 2.5 centimeter per second. Means particle is traveling from A to B through this quadrant with a constant speed of what, 2.5 meter per centimeter per second. Find the average velocity. So again, we have solved these sort of numericals, right? So what do you mean by average velocity? It is total displacement, okay, divided by total time. Absolutely correct. So what is the displacement when particle have been reached from point A to point B? What is the displacement? The shorter distance between initial and final position. So this is the shorter distance, right? So means if this is your r, this is your r, okay, then just think, what is this? This will be from Pythagoras, right? This is your right angle triangle. So this will be what? Under root r square plus r square. Just think everyone, right? So yeah, correct. Okay, so now let me tell you this. Yes, so this length I'm writing here, this distance, this you can say displacement, okay, displacement here is under root r square plus r square, which is nothing but root 2 times r will be common, okay, just check, right? And time, what is the time taken here? When the particle is moving in this quadrant, from here to here, right, in this quadrant, so the time taken by this can be calculated by this speed, right? Speed is given to you, okay, the speed is given to you, hence what is the time taken when it will reach from A to B, right? So speed is equals to let me do it here, yeah, speed is equals to distance upon time. So you can find the time is equals to distance upon speed. What is distance? Distance is quadrant of a circle, right? So 2 pi r divided by 4 and divided by speed. What is speed? Speed is 2.5, you can say, right? So that's how you can find the time as well. Okay, so now let me do it here. So your average velocity, finally your average velocity here in this case will be equals to total displacement, which is nothing but r root 2 or root 2r, you can say, divided by time. What is time? So it is pi r by 2, okay, divided by the speed. What is speed? 2.5. just check it everyone, okay. This is your time, what we have found, okay. Think all of you. So r will cancel out and it will be nothing but 5 root 2 by pi centimeter per second, okay, the unit of speed only, right? Just think all of you. Is that clear? Good, very good. Now again you have to find the average speed. So what will be the average speed? Think, in this motion the particle is moving with constant speed. The particle is moving from A to B with constant speed. So if the speed is constant, so this speed is the only average speed. Just think, this is the average speed now, right? everyone. I hope this thing is very much clear. If the speed is not changing through the motion of the particle, then the average will remain the same. Okay, let me explain you with a good example. Suppose if we want to calculate the average height of the class of the student, right? Average height of the class, right? So if each student have height 6 feet, then the average height will be 6 feet only, right? So that's how the average speed here in this case will be nothing but 2.5 centimeter per second. It is constant, right, throughout the motion. Now average acceleration we have to find. So what about the acceleration now? What to do for acceleration? Average acceleration now. A average. So the change in velocity, right? So is initially the velocity here is in this direction. Finally, the velocity will be here in this direction. Just think, everyone. Let me zoom it for you. Yeah. Initially, the velocity is tangential, right? Here in this direction. And finally, the velocity will be tangential again in this direction, right? So what is the change in velocity? Just think. So this is your initial velocity, okay? And this is your final velocity. Just think. So what is the change? So how will you find the change in velocity? Means this is your v1, this is your v2, okay, from vector. Do you know the formula of vector, the subtraction of vector? If you have to subtract vector a from b, then the formula of modulus is nothing but under root a square plus b square minus 2ab cos theta, where theta is the angle between the two vectors. Everyone just think. So if you have to find v2 minus v1 magnitude, right, then what we have to do? Again, so this is complete under root. Again, under root what? v1 square or v2 square plus v1 square minus 2 v1 v2 cos, what is the angle between the two vectors in this case? Yeah, 90. And cos 90 is 0. Okay, everyone got that? Just think. So that's how we can find v2 minus v1 magnitude, right? Means this is v2 minus v1 vector and its magnitude. This is the magnitude. Okay, I hope this thing is very much clear to you. I have just told you this concept in a very simple method, right? So now let's come back to our topic. Yeah, we have to find the average acceleration. Okay, so the change in velocity means v2 minus v1. Okay, v2 minus v1. So now again, what is that? The magnitude is simply under root. Yeah, speed. Here is what is v1? What is v1? So v1 here is in, what is v1 mod? It is simply what? It is 2.5 centimeter per second. Just think, everyone. Okay, what is v2 mod? Mod means magnitude, right? So v2 mod is nothing but 2.5 centimeter per second. Just think, all of you. Okay, just think, everyone. But here you have to find the difference in the change in velocity, right? Means the magnitude, right? I am writing the formula here in front of you. A vector minus b vector, the magnitude of this will be nothing but under root mod a square plus mod b square minus 2 mod a mod b cos theta. That's it. This is the formula, right? Just note down this formula, everyone. Star. Okay, so that's what we are using here again. So v1 square means 2.5 square. Okay, 1 minute, let me write it more clear. 2.5 square plus v2 square, again 2.5 square, okay, minus 2 v1 v2 cos theta. Okay, so 2 v1 v2 cos theta. Just think, all of you. So it is nothing but 0. Just think why. It is nothing but 0 because theta is the angle between v1 and v2, which is 90 here in this case. Okay, just check, which is 90 degree. Okay, so that's why this is nothing but what? 2.5 root 2. Okay, this is your change velocity, right? And you have to divide by time also. So you have to divide by time. This is means what is, again, let me make it more clear to you. Yeah, so this is your change velocity divided by the time. Time interval is what? So time is same again, right? The time from reaching of particle, the time taken by particle from reaching from point A to B is same this time, right? Just check. We have calculated with that, right? How much time it has been taken? T is equals to, yes, that distance upon speed is equal to distance upon time. Okay, so time is equals to distance upon speed. That's it, right? Just check. So that's what we have done. Okay, so yeah, so time is again here we can say pi, okay, r by 2 divided by 2.5. so that's it. This is your, you can solve it, right? And this will be your change in you can say this is your acceleration here. Okay, so if I'll solve it, it will be 2.5 root 2 divided by pi. Okay, r, what is r is again 5. Check, r is 5 centimeter, right? Yes, r is 5. And this yeah, r is 5 into this yeah, this 2 into 2.5 will go up, okay, in the numerator, right? So it will become 5. Okay, so that's it. This is your answer, final answer. I hope this thing is very much clear to you. Okay, so this is your acceleration, a average. Okay, if you have any doubt, you can ask in the comment. I will check and answer you. Okay, so the solution is also attached with this. I hope this thing is very much clear to all of you. Just check. This is your final answer. You can solve and check again. All right, so that's what they have done to find the change velocity, what we have done from formula. Okay, we have just used this formula. Okay, a minus b. Here what we have to do, we have to do v2 minus v1 vector. All right, and we have to take the mod. That's it. So the formula here we got will be nothing but v2 square, v2 mod square plus v1 mod square minus 2 v1 v2 cos 90 here in this case. Okay, I hope this thing is very much clear to all of you. So that's all. Now let's proceed to our next concept, and which is nothing but the concept of instantaneous velocity and instantaneous acceleration. In this lecture we'll go with the concept of instantaneous velocity. So students, let me give you an example. Suppose a particle started from this point A and reached to this point B, right? In this, the particle have been moved like this, right? Okay, so when the particle started from here and after covering this path, it reached to point B. Okay, so there will be a average velocity, right? What do you mean by average velocity? Means the average, means the total displacement upon total time, that will be your average velocity. Okay, again, what is the average acceleration? Average acceleration. Okay, so what is your average acceleration? It means change in velocity upon total time, right? So, but students, suppose this particle has to move from here to here, but in between the velocity is not uniform, right? The velocity is not constant, the acceleration is not constant. Okay, it has been increased, decreased sometimes. Okay, so suppose if you have to find the acceleration or the velocity at this particular time, at this particular instant, suppose at t equals to 2 minute, you have to find the acceleration, the velocity, then that particular instant velocity, okay, at the velocity at that particular instant, the velocity at that, the acceleration at that particular instant will be known as the instantaneous acceleration or the instantaneous velocity. Simple, राइट. सपोज इन हिंदी लेट मी टेल यू दिस. सपोज एक स्टूडेंट है, ठीक है, जो ए से बी पे जाता है. या मान लो कि आप यहाँ से अपने घर से अपने नानी घर जाते हो, तो भैया आप एक स्पीड से तो जाओगे नहीं, है ना. आप कहीं पे बाइक रोकोगे, ठीक है, कहीं पे भाई तेज़ भगाओगे, ठीक, कहीं पे स्लो कर दोगे, तो आपकी वेलोसिटी जो है वो कम ज़्यादा होती रहेगी, राइट. ओके, सो अगर आपसे पूछा जाए, आपको अपने नानी के यहाँ जाने में 2 घंटे लगते हैं, 2 आवर्स, राइट. तो आपसे पूछा जाए कि भैया कि आपकी वेलोसिटी t इक्वल्स टू 30 मिनट में क्या थी. सो जो वेलोसिटी t इक्वल्स टू जस्ट 30 मिनट पे होगी, दैट विल बी योर इंस्टेंटेनियस वेलोसिटी एट दैट पर्टिकुलर इंस्टेंट. जो एक्सेलरेशन उस 30 मिनट पे होगा, दैट विल बी योर इंस्टेंटेनियस एक्सेलरेशन. आई होप ये चीज़ समझ गए, फिजिकली फील कर गए, है ना. आई होप दैट यू अंडरस्टूड दिस फिजिकली, राइट. बट हेयर इन दिस बट नाउ आप कैसे निकालोगे, हाउ विल यू फाइंड दिस इंस्टेंटेनियस वेलोसिटी और इंस्टेंटेनियस एक्सेलरेशन. सो द इंस्टेंटेनियस वेलोसिटी, clear, is the velocity at particular instant, right. What is instantaneous velocity? So velocity at particular instant, right. And what is your instantaneous acceleration? Instantaneous acceleration means the acceleration at particular instant. Right, now how will you find this particular instantaneous velocity and instantaneous acceleration? So we can only find this with graphs. Okay, with graphs. Okay, suppose we have one VT graph. Okay, velocity versus time graph. Okay, so from here, from this VT graph, you can definitely find what will be your velocity at particular instant, right, at particular time. Or suppose we have AT graph. Okay, so again we can find the instantaneous acceleration, instantaneous velocity. Okay, instantaneous acceleration we can find it, right? Or we can find it from the equations. From equations we can also find it. Suppose if v as a function of time is given to you, then you have to simply put the time and find the velocity, right? That will be your instantaneous velocity. Or suppose here equation is given a as a function of time. Okay, as a function of time means suppose a is equals to, you can say, 2t. Okay, so you will put t equals to 1, you will find the acceleration. You will put t equals to 2, you will find the acceleration, right? So that's how we can move. Okay, so now let me conclude this. So the formula of instantaneous velocity, okay, is equals to, this will come from here. Okay, will come from here. The formula of instantaneous velocity will come from here. So what is this? This is your average velocity. When this delta t tends to 0, then it will become your instantaneous velocity, and this delta x by delta t, x for displacement, okay, will approaches to dx by dt, and this d by dt of x means you have to differentiate your x. Okay, suppose x is equals to t square, means this is x, the displacement as a function of time. So you will differentiate this, means d by dt of t square, just check, which will be nothing but 2t. So this will be velocity now, instantaneous velocity, means velocity at a particular instant. So this v is equals to instantaneous velocity is equals to simply 2t. So if you have to find the velocity at t equals to 4, you will simply put t equals to 4 here, and your velocity at t equals to 4 will be equals to what? At t equals to 4 minutes, suppose. At t equals 4th minute, your velocity will be simply equals to 8 meter per second. That's it, right? Just think everyone. Just check. So this is the simplest way I have told you what will be your instantaneous velocity, right? Again, now let me tell you t equals to 4 will be simply 8, right? Clear? Now let me tell you what is instantaneous acceleration. Okay, so physically you know what is instantaneous means the acceleration at a particular instant. At a particular instant, at t equals to 1 second or minute, at t equals to 2 second or minute, right? That's it, right? How will you find this? Again, as acceleration is equals to delta v by delta t. This is your average acceleration. So your instantaneous acceleration will become nothing but this delta t tends to 0, and it will become the differentiation of d by dt of your velocity. Means if we will take this example only, then the differentiation of nothing but 2t, and it will be nothing but what? It will be simply 2, okay, meter per second square, because it is acceleration. Just check, right? So now you can put t equals to 1, t equals to 2, t equals to 3, and you will have your acceleration from this, right? I hope this thing is very much clear. So before moving further, let us solve one numerical based on this concept. Okay, so this is the numerical here. Yeah, very simple concept, very simple question, and in the next lecture we'll solve some more questions, some more numerical based on the concept of instantaneous velocity and instantaneous acceleration. So let us solve this first. Let me read it for you. So the position of a particle is given by the equation x equals to 3t cube, right? So this is the position, right? And you have to find the instantaneous velocity at t equals to 2 second, t equals to 4 second, using the definition of instantaneous velocity. So what do you mean by instantaneous velocity? V is equals to dx by dt. Clear? If we have to find the acceleration, then acceleration will be dv by dt. Okay, means we have to differentiate velocity here for acceleration. We have to differentiate position for velocity, okay, or displacement for velocity, right? So the differentiation of 3t cube divided by means differentiation of 3t cube with respect to time, right? So it will be nothing but what? Just check everyone, all of you, just check. Yes, So it will be simply, yeah, it will be 9t square. This is your instantaneous velocity. So now in this question you have to find the velocity at t equals to 2 second and 4 second, right? So what we'll do is we will find the velocity at t equals to 2 second, 4 second. Okay, so velocity at t equals to 2 second. What to do here? You have to just do one thing. Yeah, let me do it here for you. Yeah, so now you got your instantaneous velocity formula to be as 9t square. So velocity at t equals to 2 second, just put t equals to 2 here. You will get 9, 2 to the power 2, it is 4. Okay, so it is nothing but 36 meter per second. Just check, right? Again, velocity at t equals to 4 second. So you will put t equals to 4, it will be 16, right? 16 to 9, 144 meter per second. That's it. If you have to find the acceleration, then you have to differentiate the velocity. It will be the differentiation of velocity d by dt of what? 9t square. Just think, everyone. All right, now it will be 18t. Now you can find the acceleration here also. Okay, you can put t equals to 1, the acceleration will be 18 meter per second square. Okay, if you put t equals to 2, acceleration will be 36. So that's all. Okay, this is how you can find the instantaneous values of velocity and acceleration. I hope this thing is very much clear to you. So the answer is 36 and 144. Alright students, very simple question. In the next lecture, we will move some more better good questions to deal with the concept of instantaneous velocity and instantaneous acceleration. I hope this thing is very much clear to all of you. Thank you students. We'll meet soon. Stay blessed, stay motivated, stay focused and stay tuned. Okay. Jai Ram Ji ki Har Har Mahadev. Bye.